video quality not so good. Will do. Who's on mic? It's actually, the irony is that the mic around my neck is not functional. It's there so I can hear myself talk digitally there, but I have to hear myself talk because, well, otherwise I slur or repeat things more too loud. That's my first project on this camera. I am going to explain it as well, because I have a couple people ask me, and a lot of people tell me to know. So, let's define a tesseract. A tesseract is a 4-dimensional object projected into 3 dimensions. It is represented in 3 dimensions as a 4-dimensional object, much the same way that a cube is represented on paper. 3 dimensions as you know it. XYZ. Each of these dimensions are 90 degrees from each other. Yeah, that's correct. I really should look that up. Other than the sun, like an idiot. Give me the first one. Orthogonal. Yeah. Yeah. Orthogonal. I was close. It doesn't matter. So, orthogonal, 90 degrees to each other. Kind of like half opposite. So, 2 dimensions is a square. There you go. Square is x2 side by side. Right angle is represented here. 3 dimensions is a cube. Information lost from 3 dimensions to 2 dimensions. So this cube doesn't look as cubey as it would if it were right in front of you. Moving on. The hypercube. Poorly drawn. Oh well. I gotta fix it. Better. Now the hypercube, or the tesseract, hypercube being its actual shape, tesseract being its representation, or something like, this is a squared cube. Essentially it is a cube squared, so it is x3 times 2, so x4, well, x times, you get it. Every angle that you see is a right angle. Every side that you see is exactly the same length. If you look at the middle cube as you see it, if you were to stare at a tesseract, broad side, don't move, and it will look exactly like, in fact you will not know the difference from a cube inside of another cube, seemingly connected. But if you move, then it warps. See, the thing is, that inner side there, if you look at that little cube, the side facing you, or appears to be facing you, its dimensions, if measured, are the exact same as out here. So these lines connecting, right, into the middle, that's another complete cube in dimensions. Intriguing. So essentially this has twice the sides of a cube. Twice the sides. This is surface sides, by the way. If you can call it surface. Yeah. So it's not like it's inside. It's not folding on itself. It's actually the inside as you see it is also on the outside. Just on a different side than you can see. See, the things that are constant is the fact that there is there's a distance from the center, and it's radial in that sense. It's just really hard to comprehend. If you were to stand inside this one side here, if you could, in between the little one and the big side, you know what I mean? It would look like a big cube room, perfectly shaped. Just a cube. It's actually not a bad drawing. I might have gotten it backwards. Actually, no, I didn't. Yeah, it's about right. How long is this? I better not overdo it. Okay. Well, that'll do.